Welcome back, everybody. Today we're going to be taking another look at a linear programming example where we're selling salads at a lunch stand. We're going to read and annotate the problem first. The problem says a lunch stand makes 75 cents on each chef's salad. Let's circle 75 cents and underline chef salads. And $1.20 on each Caesar salad. Let's circle $1.20 and let's underline Caesar salads. On a typical weekday, it sells between 40 and 60 chef salads. So on my chef salads, we're doing between 40 and 60. And 35 and 50 Caesar salads. So we'll circle the 35 and 50 Caesar salads. So that's just representing the typical number that we sell. The number sold has never exceeded 100 salads, so that's the total. I'm going to denote that with a box just to show that it's a little bit different. How many of each type should be prepared to maximize profit? Of course, anytime we're selling something, we want to make as much money as possible. Part A says identify constraints for the scenario, and go ahead and let X be our chef salads and Y be our Caesar salads. So for our chef salads, we want that to be between 40 and 60. So 40 is less than or equal to X, which is less than or equal to 60. And on the Caesar salads, that's our Y, we want it to be between 35 and 50. So Y is greater than or equal to 35, or 35 is less than or equal to Y is less than or equal to 50. That's our constraints for this situation. The last constraint that we might want to say is this last one here where we say the number of chef salads plus the number of Caesar salads is less than or equal to 100 total salads. Now I'm going to rewrite my constraints up here since I just erased them. So now let's graph these three constraints on our graph paper. First we'll graph our constraints for the chef salads, and I'm going to label my x-axis with chef salads and my y-axis with Caesar salads, just so we don't forget while we're working this out. So X is between 40 and 60. And then for my Caesar salads, we're between 35 and 50. So we'll go to 35. You can go ahead and tell where our feasible region is going to be, somewhere in this rectangle that we've created. Somewhere in this region right here. But we have this third constraint, which might change our rectangle slightly. It says X plus Y is less than or equal to 100. Notice my Y-axis only goes up to 60. So my Y-intercept, if I were to rearrange this, would be somewhere up in this area. I don't want to make a guess though. And so another way that you could graph this is just do a little XY table. Let's start with some simple points. If X is 50, Y is also 50. If X is 40, Y is 60. And if X is 60, Y is 40. You probably did something similar to this in Algebra 1 where you started off by graphing using XY tables, but I'm going to use these 3 points to make my graph here. So I'm going to go ahead and plot them. So 50-50 lands right here. 40-60, 40 on my x-axis and 60 on my y-axis right up here. And then 60-40, 60 and there's 35, there's 40. So we see a straight line formed between these 3 points. We can go ahead and graph the line through there. Now let's take a look at our inequalities. So X is between 40 and 60. That would be any of these. Y is between 35 and 50. So that would be any of these. And then for this last inequality, X plus Y is less than or equal to 100. So we want to take this line, this diagonal line that we drew here, and we want to shade all the area below it, also inside that box. So you see this polygon that we've got here. That's our feasible region. Let's look at the feasible points. Unlike the last example where we had 4 feasible points, we see this polygon gives us 1, 2, 3, 4, 5 feasible points. So let's go ahead and list those. We've got 40, 35. We've got 40, 50. We've got 50, 50. We've got 60, 35. And we've got 60, 40. Now we could test all 5 of these points, but like in the last example we looked at, there's probably some points that we could eliminate. Let's see if they have any x variables or y variables that are the same and kind of guesstimate from there which we can eliminate. If we're selling 40 chef salads and 35 Caesar salads, or we sell 40 chef salads and 50 Caesar salads, we know that we would make more money by selling this 40-50 combination than the 40-35. So I'm going to go ahead and mark that first one out. If we look at these with chef salads the same, 60 chef salads and 60 chef salads, I know I'd make a little bit more money by selling 40 Caesar salads. So we'll go ahead and mark that one out. On this last one here, we've got 40-50 and 50-50. Well, here I'm selling 10 more chef salads, so that should give me a little bit bigger profit. So really, I just need to check these two, the 50-50 and the 60-40. So the objective function here, which models the maximum profit, looks something like this. The profit is equal to the amount that we make on a chef salad times the number of chef salads plus the amount that we make on a Caesar salad times the number of Caesar salads. Now, I don't have this right in front of me, so I'm going to flip back a slide. And our problem said that we make 75 cents on each chef salad, and we make $1.20 on each Caesar salad. Okay? So what we're going to do with this objective function here is substitute these feasible points into it to see which one actually gives us a bigger profit. So for our first feasible point, 50-50, we get the profit is equal to 75 cents times 50 chef salads plus $1.20 multiplied by 50 Caesar salads. If we work this out, it gives us $37.50. And $1.20 times 50 gives us $60. So if we add these two together, we get a profit of $97.50. Okay? For our next feasible point, we're going to do the same thing. The profit is equal to 0.75, but instead of 50, we're going to use 60 there, plus $1.20 times 40. 75 cents times 60 is going to give us $45. Plus $1.20 times 40 will give us $48. And if we add these two together here, we'll end up with $93 even. So you tell me, which one are we going to make more money on? 50 chef, 50 Caesar, or 60 chef and 40 Caesar? And so to make the most money, we would need to use this option right here, which was 50 chef and 50 Caesar. And that would maximize our profit for the constraints given based on past data for this lunch stand that was selling chef salads and Caesar salads. Hopefully this was helpful to you. Thanks for watching.